Hello everyone, very good evening to one and all of you. I hope I'm audible and visible. So if not, any one of you can confirm it. So let's wait for 5 to 10 minutes so that everyone can join the session.
Good, e-
Good evening, good evening.
good evening, madam.
Yeah, good evening. We will start the session in within 5 minutes. So, okay, let's start the session. Hello everyone, my name is Pooja Verma. I am the Himachal Research Scholar from IIT Kharagpur, and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is the week 7 live and interactive session on computer vision. So I hope all of you have gone this week video lecture. So here we will solve some numerical or conceptual problems which will be very similar to the assignment problems so that you can able to solve the assignment questions. So for this week, the course content is related to the feature matching and model fitting. So different feature matching and model fitting techniques you must have been studied. So here I am not going through the theoretical or some concepts. Directly we will solve some questions. I hope all of you have done this week video lectures. So the first question is, given two features, each of size 4 as f uh, is given as 4124 and g features as given 9122. So compute normalized cross correlation and cosine similarity respectively. So how we can calculate this?
F minus G. We have to do F minus G, no?
Okay, how we can calculate the normalized cross correlation?
No idea. No.
Okay, so there is a formula for both cosine similarity and normalized cross correlation. From there we can calculate. So I am solving here. You can also parallelly solve it. Otherwise you can solve it later also. Okay. So here the two feature vector f and g are given. Now we need to calculate the normalized cross correlation and cosine similarity. Okay. So to calculate the normalized cross correlation between the two feature vectors, that is f and g, it is calculated by this formula. I am representing the normalized cross correlation by NCC. Okay, between the two variables f and g. So here the formula is this. I will vary I1 to n, where how many feature vector? Here it is a feature vector of size 4. Here it is given. So n will be the 4 only. Okay. So here fi minus f dash bracket gi minus g dash. And here f dash and g dash are the mean of f and g respectively. So here also root of I is equal to 1 to n fi minus f dash square, and I will vary 1 to n gi minus g dash whole square. Okay, so this is a formula to calculating NCC, normalized cross correlation. So yes, so till now can you calculate? Okay, so till now can you calculate the f dash and g dash? You can say that mean of f and mean of g, and let me know what will be the values of mean of feature vector f and mean of feature vector g. Similarly, we can calculate the cosine similarity. Also, the formula for cosine similarity is Cosine similarity of f of g is calculated by f into g divided by f and g. And here it is a normalized values at the root mean square of the feature vectors. Okay, so let's calculate. Already f feature vector f and feature vector g is given. So the mean of feature vector f is represented by f dash. That is, we need to take the average of the all the feature vectors. So that is 4 plus 1 plus 2 plus 4 divided by total number of how many features? 4. Total number of feature vectors. So what is the value? 11 by 4, right? So if you divide it, you will get 2.75 here. Similarly, we have to calculate the mean of feature vector G also. The mean of G is represented by same G dash. So take a average sum of 9 plus 1 plus 2 plus 2 divided by 4. So 14 by 4, right? What value you will get? 3.5. Okay, you will get the 3.5, not 7.5, 3.5 I think. Yeah. Okay, so now I'm just taking another slide to calculate the normalized cross correlation and cosine similarity.
ट्यूशन का बोर्ड लगा देते हैं
Swati, can you mute yourself? Okay, so let's calculate first the normalized cross correlation f comma z. Where lot of values will be there. So it is a summation of fi minus f dash. So here I will take, let's take I is equal to 1 to 4. It will vary. So fi minus f dash and gi minus g dash. Similarly, in the lower side also, in the denominator, I is equal to 1 to 4, fi minus f dash, and I is equal to 1 to 4, where it is a whole square, gi minus g dash whole square. So let's put all the values. So here, when we will take I is equal to 1, that means f1. So f1 value, first value is 4, right? For the feature vector f, the first value, it is a f1, f2, f3 and f4. Similarly, you can represent it I, g1, g2, g3 and g4. Okay, so let's take it first one, and actually we have to multiply and sum all the values. Multiplication of these two and plus sum. So first value is 4 minus 2.75 and it should be, and now g1 is 9 minus 3.5, right? It is a multiplication of these two plus, then again I is equal to 2, so f2 minus f dash multiplied by g2 minus g dash, right? Plus 1 minus 2.75 and 1 minus 3.5, right? Now plus, take the other values also, 2 minus 2.75 multiplied by 2 minus 3.5. Okay, then again take here, I'm just going to like this. It is a little bit clumsy. So I think if you are saying you can understand. 4 minus 2.75 multiplied by 2 minus 3.5. So till now, can you calculate these values in the upper part? So I'm taking the division like this. In the lower part also, root of it is a root of all the values. So first we have take to this one, then this one, multiplication of these two values. Okay. So here it is again 4 minus 2.75 square plus 1 minus 2.75 square plus 2 minus 2.75 square plus 4 minus 2.75 square. Okay, so this one is for feature vector f, right? Now the this one is in a last bracket and then it will be multiplied by next feature vector. So now 9 minus 3.5 whole square plus 1 minus 3.5 whole square. Now next one 2 minus 3.5 whole square plus 2 minus 3.5 whole square. Okay, so these are the values. Now next one is you will get here 4 minus 2.75, you will get 1.25 multiplied by 5.5 plus minus 1.75 multiplied by minus 2.5 plus minus 0.75 multiplied by minus 1.5 and plus 1.25 multiplied by minus 1.5 here again. Okay, in the denominator part, we will get root of 1.25 square for this one plus minus 1.75 square plus minus 0.75 square plus 1.25 square. Okay, this is in for feature vector f, and next one is the multiplication of feature vector g. So again 5.5 square plus minus 2.5 whole square plus minus 1.5 whole square plus 1.5 whole square we will get here. Okay, so after that I'm writing here and just removing this formula. I hope all of you have noted down. Okay, after this I'm just writing here. Okay, so the values is in the you will get in the upper side 6.875 plus 4.375 plus 1.125 and minus 1.875. So you can check it also. Here you will get root of this one 1.5625 plus 3.0625 plus 0.5625 plus 1.5625. So here I can made some mistakes also during calculation. So just you see check also and multiplied by here 30.25 plus 6.25 plus 2.25. Here you will get again 2.25. Now add these values all those and multiplied by the lower side. So in the numerator, you will get the value of 10.5. In the denominator, you will get root of 6.75 multiplied by 41. So here, if you just multiply and divide it, so just check here what values you are getting. So if you just multiply these two values, you will get, I think, 276.75. And overall values, I
బాగా
think you
చేస్తుంది.
need to get these. Now just calculate root of 276.75. So for the cosine similarity index, here actually I'm just 0.41 something, but actual values here you are getting 0.63. Okay, so here some calculation I think mistake I have done. So you just take it. These value you should get. Okay. Now how we need to calculate the cosine similarity. So already we have the feature vector f and g. So already formula I have written here for cosine similar f into g and divided by double mod of f into g. Okay. So I am calculating it here. So cosine similarity f g. So here f into g, f and g. So here the feature vectors that we have here. So first we need to multiply the first values of the feature vector. So our feature vector f is 4, 1, 2, 4, and feature vector g is, it is given in the question, 9, 1, 2, and 2. So just we need to take multiplication. So in the first place 4 into 9, right? Then plus 1 into 1 plus 2 into 2 plus 4 into 2. Okay, in the lower side it is a root, it is a double mod. So how we can define the root of every value square? So 4 square plus 1 square plus 2 square plus 4 square. Okay, similarly for this one, this value is also, so 9 square plus 1 square plus 2 square plus 2 square. Okay, so in the numerator part you will get 36 plus 1 plus 4 plus 8 divided by root of, here you will get 16 plus 1 plus 4 plus 16 multiplied by 81 plus 1 plus 4 and plus 4. So if you add these values, you will get here in the numerator 45, 49, and in the denominator root of 37 and root of 90. Okay, so if you just calculate it further, you will get 6.0828 here multiplied by 9.4868. For root 90, it is for root 37. If you multiply further, you will get 57.703, and the overall value, if you divide it, you will get 0.8491. So this is a cosine similarity for this question. Okay, so from here option B is the correct answer for this question. Okay, what we have calculated, this is the basic two formula to calculate normalized cross correlation and cosine similarity. Okay, okay, so now moving to the next question. The next question is, anyone have any doubt? Can we move to the next question? Okay, so moving to the next question. Next question is, let D1 10 and D2 8 be the distances to the nearest and next nearest neighbors from the query's feature respectively. For threshold limit of 0.4, choose the correct option. So options are: option A is nearest neighbor distance ratio D1 by D2 accepts nearest neighbor as a match. Option B is nearest neighbor distance ratio D1 by D2 reject nearest neighbor as a match, and or option C is both A and B. Option D is none of above. So which answer can be a correct one? Can you just guess, or if you would like to know, please try to answer at least this question. Then I will solve it here.
Madam, maybe A answer.
Okay, maybe. Okay, let's see. So to calculate nearest neighbor by the distance ratio, it is calculated given to distance ratio first we need to calculate, that is d1 by d2. Okay, so here d1 is given as 10 right here, and d2 is given 8. So ratio can be calculated by 10 by 8. So what value we are getting here? 1.25, right? So to calculate the whether it is accept the nearest neighbor or rejects the nearest neighbor, we need to compare the distance ratio with the threshold limit. So the given threshold limit is 0.4, right? So if the ratio is less than the threshold, the nearest neighbor is considered a strong match and it is accepted. And if the ratio is greater than or equal to the threshold of the nearest neighbor, is considered an ambiguous match and it is rejected. Okay, so in this case, our calculated ratio, so I'm just here writing in short. First one is if the ratio, ratio is less than threshold limit, what it is, it accept, or if the ratio is greater than or equal to the threshold limit, it will reject the next nearest neighbor. Okay, so in this case, in our case, or in this case, ratio is greater than, right? the threshold limit, that is calculated value is 1.25 and given threshold is 0.4. So in this case, it will reject the nearest neighbor. Okay, so answer B is the correct answer. Nearest neighbor distance ratio d1 by d2 reject nearest neighbor as a match. Okay, because its ratio is greater than the threshold given threshold limit. Okay, option B is the correct answer. Yeah, option B is the correct option. Okay, so now moving to the next question. Our next question is two probability distributions for four discrete values are given as P is equal to 1 by 4, 1 by 4 and 1 by 4, 1 by 4. And Q is given as 1 by 2, 1 by 4, 1 by 8 and 1 by 8. Compute KL divergence of P and Q, that is KLD P equal to Q. Okay, so how we can calculate and what is a KLD? It is a the full form of KLD is Kullback Leibler divergence, right? So how we can calculate it? Anyone have any idea how we can calculate this divergence? So for calculating the KL divergence of P and Q, the formula is written as a dKL P equal to Q, where I will vary the total number of the features. They have four discrete values are given. So Pi log Pi divided by Qi. Here you can take it as a natural log. Here it is taken as a natural log. Okay. Or we can write it ln also for this one. So while calculating, we will take here the natural log. So I'm directly writing here ln. Okay. So the given distribution P and Q. So here we can see that P has an equal distribution for all, right? So the P distribution is uniform for all values. The distribution of P is uniform over all values, right? So P of I will be 1 by 4 itself because it has a equal distribution across. So we can write this one D here, here 1 by 4 or here I 1 to 4, right? Because here 4 discrete values are given only ln 1 by 4 Q of I. For Q it will vary 4 to. So now compute for each term of the Qi. Now compute for each term of Qi. So let's for I is equal to 1 if we are taking. So let's say we are here just taking it as a, then we will make a summation of all the values, otherwise it is very difficult to calculate. So I'm just taking P1 here. Okay. So 1 by 4 ln the upper part and 1 by 4 P1 is sorry Q1 because we are calculating I, so 1 by 2, right? So 1 by 2. So what value will be here? You will get ln 1 by 2, right? So now if you take the natural logarithm of 1 by 2, you will get here minus 0.6931, and if you overall just divide or multiply this, we will get 0 minus 0.1733. Similarly, we need to calculate for I is equal to 2. So I'm just taking the another side to calculate it. So here for I is equal to 2. So here I am taking P2. Here 1 by 4 ln 1 by 4. What is the value for Q2? It is again 1 by 4 itself. So here you will get 1 by 4 ln 1. So the natural log for 1 is 0. So overall value for P2 you will get 0. Now calculate for I is equal to 3. So here you will get P3. So it is a 1 by 4 ln 1 by 4. What is the value for Q3? Let's see. It is a 1 by 8, and for P4 it is also 1 by 8. P3, P4 values are same, so you will get the same values. So 1 by 8, where you will get, so 1 by 4 and 2, right?
Yes,
Natural
ma'am.
log 2, you will get. What will your value for natural log 2? Can you just check in the calculator and let me know? 1 by 4 multiplied by, I am writing here, you can calculate 6931. Okay, so if you just divide and multiply it, you will get 1733. For I, 4 the value is same, so P4 itself you will get 0.1733. Okay, now all the values you have got, so we have to add the values, all the values. Calculate the CL divergence. So add all these values, minus 0.1733 plus 0 plus 0.1733 plus 0.1733. So these two
ఏంట్రా
values will be,
సౌండ్
yes,
కిచెన్ లో ఏదో టుక్మన్ సౌండ్ వచ్చింది.
look, so you will get the value is 0.1733. You can take log base 2 also, and you can calculate, then for that you will get, if you are taking log base 2, taking log base 2, then you will get the value for dkl, but most of the time it is calculating by the natural log, not log base 2 or base 10. Okay, just remember this one. So here you will get the 0.25. In the both of the cases, no values are matching because all values are given in the negative term. So option B is the correct answer for this question. Okay, yeah, option B is the correct answer for this question. Okay, so have you understand this question? Can we move to the next question?
Yes, ma'am. Sure.
Okay. Okay, so moving to the next question. The next question is choose the correct options. So option A is group transform requires appropriate resolution of discretization of the grid in parameter space. Option B is if grids are too coarse to many different points in image space mapped to single bucket. Now option C is if grids are too fine, some points may not be exactly collinear both different buckets. Or option D is if transform does not require any discretization of the grid in parameter space. So which option is the correct one? Anyone have any idea? Can you guess the answer for this question? At least guess for this question. Then I will explain it in detail. Okay, option A. Okay, so let's break down in the detailed explanation. Okay, Silavati. Okay, let's see. Now, the explanation is the correct options are A, B, and C. So let's see what is a loop transform. So the loop transform is a feature extraction technique that is used for image analysis to identify lines, circles, or other shapes. It will work by transforming points from the image space to a parameter space where they vote for a set of possible shapes. And the most voted for parameters in this space correspond to a shape present in the image. So this process fundamentally relies on the discretization of the parameter space. So how it will work? So first we need to extract the features from the image to identify the is a shape of that any image. Then we need to transform it in a parameter space, and then we make a voting, a set of vote. So what is a possible shapes? So whatever shapes got the most voted for that parameter space, then that shape presents the image. And this process basically done by discretization of the parameter space. So option A is Hughes transform requires appropriate resolution of discretization of the grid in parameter space. So in the parameter space, as we know that the example is P minus theta space for lines is not a continuous. It's divided into a discrete grid of accumulator cell, or it is also called as a bucket. So each point in the image votes for all the buckets it passes through in this parameter space, and the final count in each bucket determines the likelihood of the line with those specific parameters existing in the image. So therefore, the resolution of the grid is critical factor
ఇప్పుడు బి
for the
దిగించాను
algorithmic
మరి అదే ఫీల్డ్ లో ఉన్నాము
performance. So this statement is
ఏం ఓపిక
correct.
వల్ల అన్నీ ఏదో
Please
చేస్తా
mute yourself, everyone, so that class will not get disturbed. Okay, so this statement is correct. That is, loop transform requires appropriate resolution for discretization of the grid parameter space. Now, next options are if the grids are too coarse, too many different points in the image space mapped to a single bucket. So this is also a correct statement. A coarse grid means that each bucket represents a large range of parameter values and consequently from the different non-collinear points or from the different distinct lines can fall into the same bucket. That will lead to a high count, and this can result in a false positive where the algorithm detects a line that does not actually exist in the image. So as a multiple unrelated points, they contribute to the same bucket. So this is also a correct statement. And our next one is if grid are too fine, some points may not be exactly collinear voting different buckets. So it is also a possible case. A very fine grid means that each bucket represents a very small range of parameter values. In the real world images, due to noise or discretization error, points belonging to the same line might not be perfectly collinear. So their votes in the parameter space would be slightly offset, or instead of accumulating in a single bucket, they can be distributed among the several neighboring buckets that cause a vote count in a single bucket to the remain below the threshold, that leading the false negative. So this statement can be correct also. No, next statement is or option D is Hooke transform does not require any discretization of the grid in the parameters. So as already we see or explained above, huge Hooke transform requires a discretization of the grid. So the core principle of Hooke transform is the use of voting system on a discrete grid. Without discretization, it is not possible to vote or identify the parameters that are most likely to represent the same. So this statement is incorrect. So it is a so option A, B, and C. The three statements are correct here. Okay, option A, B, and C are the correct statement or correct options. Okay, so detailed explanation I have added here. You can see later also. Okay, so moving to the next question. Now next question is consider points in 2D plane, that is 5, 8, 12, 16, 9, 11, 2, 4, 18, 14, 6, 20, 10, 5. After building a 2D binary search tree following the given order, which of the leaf node is in the rightmost part of the tree? So how we can solve this question? So here some points in the 2D plane is given. Now we have to build a 2D binary search tree in the following given order, and then we need to find out which leaf node in the rightmost part of the tree. Okay, so already we know that a 2D binary search tree, also known as a KD. Here K is equal to 2, so that's why here it is a 2D plane. It is written. Okay, so the key principle is that at each label of the tree, the split based on the different coordinates. Okay, the root nodes split based on the x coordinate and its children split based on the y coordinates. So we will see while we are solving the question. Okay, and their children split based on the again x coordinate and so on. So first it will split on the x coordinate, then y, then again x, then again y, like that. Okay, and nodes will be inserted in the given order always. So this order is given. So let's see how we can build a 2D binary search tree. So anyone have any idea how we can build the 2D binary search tree? Okay, so let's solve it. Okay, so first point is given as a 5, 8, right? So we need to take in the only in this order. So first is given as a 5, 8. So we can say that it is a main node. Okay, it or we can say that it is a principal node. So let's take first 5, 8. Now we need to check the next given order. So next given order is 12 and 16, right? So we need to, it is a x coordinate, it is a y coordinate. Always we know that x and y, it is always written x and y. So already I have told you the root node is split based on the x coordinate. It will split based on the x coordinate. Okay. So first we will compare the x coordinate. In the next node we will compare first x, then based on the y coordinate both. Okay. So x coordinate for the root node is 5 and x coordinate for the next given order is 12. So here 12 is greater than, that means next given order is greater than the root node x, right? So that means it will split into the right. It will go in the right of the root node. If x coordinate, that is for the root node is greater than this one, let's say if there is any value 4, so it will goes on the next, I mean left, okay, left of the root node, okay. So here the next given order, it is 12, so it will go on the right side, okay. So here we will write 12, 16. So here we can write like this, 12 is greater than 5. For that, it is gone to the right, okay. So now we will take again the next value. The next order is our 9, 11. So 9, 11. So here again, for the root node is 5, 8. I can remove it here.
9 is also greater than 5, so it takes again right path, right?
Okay, it will again goes on the right path, but already we have in the right path. So again we will distribute it based on the y node, okay, y coordinate, sorry. So it will come to the right part, already we know that. Then again we will split this based on the y coordinate. Now just check here the y value, what is the y value of the next, this one 11 and this one is 16, right? So here the root node for this value is this one, so it is 16 and this is 11. So that means this 16 is greater than 11. So it will go on the left. Okay.
Left side.
Yeah.
Yes.
It will go on the left. Okay. Now take the next value. Next value is 2 and 4. So first 2 and 4. So here 2 is less than 5. First we need to compare with the root node. This is principal node. Or we can say depth 0 based on x always. Here it is depth 1. It is a y based on the y coordinate. Here again it is a depth 3. If any value will come, sorry, depth 2, it will again based on split based on the x. Okay. Now here 2 is less than 5. Here 5 is, so it will go on the this left side, right? Left of the root node, because first value is less than of the 5. So here it will come next to 4 will come in the left side of the root node. Okay. Now we will take again the next distribution, that is 18 and 14. Okay. So just a minute. Now can you tell me 18 and 14 where it will go? Just compare it. Now you know that one. So first we will compare the x coordinate. So again 18 is greater than, right? So yeah, my pen is stopped working. So till now you can solve it. So 18 is greater than to the 5. So it will again go to the right side. Now in the right side we had to just compare it with the y value. So here in the right side what value is given? 12 and 16, right? So now 12 and 16. So we need to compare the y values. So here 60 and there is a 14. So where it will go? So again 16 is greater than, here 16 is greater than the 14. So again it will go on the left side, right? It will come in the left side because this value is less than to the root node here. So it will again will come to the left side, and in the left side we need to again compare with this one to the x coordinate. So here it is a x coordinate for this value is 18 and here it is a 9. right? So what is the value? So for that, if we compare 9 and 8, so 9 is less than 18. So for that, it will come to the right side. So 18 and 14 will come to the right side. Okay. Now take to the next value. Next value 6 and 20. So again, here I can write 6 and 20. 6 and 20. So here 6 is again greater than x value is greater than. So it will go to the right side, right? Right side again we need to compare based on the y value. So here the y value is 20 and here this y value is 16. So this value is greater than. So it will come to the its right, right? It will come to the right of this. So this will be the full here. 620 will come here. Okay. Now we need to take the next value again. So next our next value is 10 and 5. So again 10 is greater than, so that means x value is greater of this the given order. So it will come right side. Again compare with the y value, right? So here it is a 5 and here it is a 60. So this value is greater than, so it will come to the left side, right? In the left side again we need to compare with the x value. So here it is 9, here it is 10. Okay. So that means it will come the right side. And now again in the depth 3 we need to compare based on the y value. So here the y value is 5 and here y value is 14. So this 14 is greater than 5. So it will come here to the left side. Okay. 10, 5. Okay. Because of 14 is greater than 5, it will come. If it is less than, then it will come to the. So this is a binary 2D search tree for this given order. So here leaf, what are the leaf nodes? Leaf nodes with no children, with no children.
10, 5, ma'am.
Okay, 10, 5. 2, 4 also that does not have that any children. 2, 4. And this one also don't have any children. 6, 20. Right? Now to get the answer for this one, they have asked which is the leaf node in the rightmost part of the tree. So it is a right part. Okay, so right part. So in the right part, what is the last value? That is the rightmost part of the tree. So 10, 5 is the rightmost part. It is in left, but it is a it is a part of the rightmost. Okay, it is a part of that rightmost. So that's why it is a 10 and 5. Option D is the correct answer for this question. Have you understand?
So always we need to consider with the root node, right, ma'am?
Rightmost. Yes, yes. First take the first node, root node. That first compare with the x, then compare with the y, then again x, then compare with the y. Like this only.
Okay, ma'am. Thank you.
So it is a rightmost part of the tree. Okay, 10, 5. Have you understand? A detailed solution I have given here, how to insert step by step. Already I have explained it here. You can take it from here. So the deepest and rightmost branch of the right subtree is the rightmost part of the tree. Okay. So you can see it later also. So have you understand this question? Can we move to the next question? Okay, so moving to the next question. Okay, so next question is also based on that. Consider a KD tree has been built using 3, 6, 17, 15, 13, 15, 6, 12, 9, 1, 2, 7, 10, 19 following the given order. This is a given order of the KD tree. Given a query feature Q, feature vector Q, this one, Q23, choose the nearest neighbor to Q using the KD tree through Euclidean distance matrix. Okay. So here first we need to put the 2D, here the two-dimensional. It is given in the two-dimensional only. So it is, you can see the 2D. So these points is given. Now we need to find out the nearest neighbor using this Q, the query feature vector, and we need to through Euclidean distance using. Okay. So how we can calculate it? Anyone having any idea? Okay, so let's see this question. So here first in the given points first value is 3 6, right? So it, let's say it is a root node. So 3 6. Okay. Now we need to distribute into left or right. Okay. So next value is our 17 and 15, right? So here just first we need to compare based on the x value. Depth, it is a depth 0. So based on the x. So here this the next given order is greater than the this value 3, right? So it will go to the right side. 17 is greater than 3. So this value will go again the right side 17 15 because 17 is greater than 3. Okay. Now take the next value. Our next value is 13 and 15. Again 13 is greater than 3 first. So it will again go to the right side. Now in the right side we need to here it will come depth 1. So we need to compare based on the y coordinate. So here let's see here 15 and 15 is equal, right? So 15 and 15 is equal. 15 is greater than or equal to 15. So it will again come to the right side itself. If it is a less than, then it will come go to the left side. If it is greater than or equal to, it will come to the right side. Okay. So 13 and 15 will come to the again the right side. Now it is a depth 2. We need to calculate based on the x. Now next value is 6 and 12. Okay. 6 and 12, here again 6 is greater than to 3, so it will come to the right side. Now we need to compare the 12 and 15, right? So here this 15 is greater than to the 12, so it will go to the left side. Okay. 6 and 12, here 12, sorry, 15 is greater than 12, so that's why it will go to the left side. Now our next value is 9 and 1. Okay. So here again the 9 is greater than to the root node value 3. So it will go to the right side. Now in the right side we need to compare to the y value. So here 1, here this 15 is greater than to the 1. So it will go to the left side. In the left side again, so we need to compare 12. So 12 is greater than to the, if this is, so it will go to the this right side, right? 9 1, it will go come here to the right side. Sorry, here we need to compare to the x depth, that means 9, this one 9. So 9 is greater than, this value is greater than 6, so that's why it will go to the right side. Okay. Now we need to take the next value, that is 2 and 7. Here 2, first we need to compare the x coordinate. So this here 2 is less than. So that means root node x value is greater than. So that will go to the here 3 is greater than 2. So this value will come here to the left of the root node. Okay. So here it will come to the 2, 7. Now next given order is 10, 19. Again, here this 10 is greater than 3, this root node x value, so it will come to the right side. Now we need to compare the y values of 9, this one 19. So it is greater than, 19 is greater than, right? So it will come to the left, right side again. Again compare to 10 and 13 because based on the x value. So here this 13 is greater than to this value. So where it will come? It will come to the left side of this value. Okay, so 10, 19. So we have made this binary search tree. So it is step 3. So here split will be based on y, but no values are given. So this is a final binary search tree. Now they have asked the given query feature vector q 2 3 choose the nearest neighbor to q using kd tree. Using this kd tree or 2d tree, we need to choose the nearest neighbor. Okay, which value is nearest to this query feature vector, and we need to calculate using the Euclidean distance metric. Okay, so already we know that what are the leaf nodes with no children. First we will start from there. Okay, so leaf node with no children are first 2 7 that does not have any children, this one, and 9 1 10 19, right? 9 1 and 10 19. Now we need to search for the nearest neighbor for this q is equal to 2 3 point. So we will start from the this at the root node. So I'm just going to the, I'm taking one slide to calculate the Euclidean distance. Choose the nearest neighbor for q is equal to 2 3 for that point. Okay, so for root node 3 6, so already we know that how to calculate it, the Euclidean distance 2 3 6, we can say that, and q is given as 2 3, right? Query feature vector is given as 2 3. So for that we need to calculate the Euclidean distance. So already we know that. So 2 minus 3 x minus x1 or y minus y1, you can say that, whole square, root of y x minus x1 whole square, y minus y1 whole square, right? So for that 2 minus 3 square plus 3 minus 6 square. Okay, so here we will get minus 1 square plus minus 3 square. So here you will get root of 10, and root of 10 value is 3.16, right? Right, the root of 10 value. Okay, now just calculate for other given order also. So since for the other values, how we can move forward, since 2 is less than the root node. Okay, the query feature vector x coordinate is less than the root node. So Trevor, first we will go just calculate for the left subtree. Left subtree. So now we left, our left subtree is 2 7, right? in the 2D binary search tree. So we need to calculate the distance to 27. So we need to calculate equivalent distance to the query feature vector to 27. So here it is given 2 minus 2 whole square minus 3 minus 7 square. Okay. So here you will get 0 square. Here you will get minus of 4 square. So overall value you will get here 4 only. Right. So as we can see that current nearest neighbor is 36 from point 36, that is root node, that is root 10, or we can say 3.16. Since the current best distance is root 10 is less than the y coordinate distance from the splitting plane, which is based on the y coordinate 27. Okay, so now we need to check the other nodes also. So we can say that the backtrack or check other branches also, whichever will get the lowest distance, that is the nearest neighbor to the query feature vector. Okay, so now we need to consider if any points in the right subtree, so of the original root 36 could be closer than the current best. So splitting plane for 36, that is our root node. Okay, so traverse, our next root node is which one? 17 and 15, right? So first check with the 17 and 15. Can you calculate equivalent distance for 17 and 15? So I'm just writing. Now we need to traverse to the right subtree from 36. So we will get first node 17, 15. Okay, so we need to calculate the distance to 17 and 15. So here it is a 2 minus 17 whole square 9, 3 minus 15 square. So here you will get minus of 15 square plus minus of 12 square. So from here we can clearly say that this is not the lowest distance, it should not be. So here you will get 225 plus 144. So if you just calculate, you will get 19.2. Okay, so it does not have a lowest distance. Now just check with the other value. So how we can, since 3 is less than 15, so traverse the left subtree. Okay, so in the 3 is less than the next coordinate, that is 6, 12. So we will here first move to the left side. So calculate for the 6, 12 and 9, 1 first. Okay, and here also we can see that these values are greater, very large compared to this one. So we will calculate from here. So already it is very genuine and known. It should get the high equated distance. So we can just remove it also. So we will calculate for 6, 12 and 9, 1. Equated distance for 6, 12 and 9, 1. Okay. So for node 6, 12. So I am just writing distance to 6, 12. It is 2 minus 6 square plus 6 minus 12 square. Okay. So here you will get minus 4 square plus minus 6 square, right? 6 minus 12, okay? 16 plus 36. What value we will get here? So if you just calculate it, you will get 9.85. Now similarly, we have to calculate for note 91. So distance to the point 91. So here it is 2 minus 9 square plus what will 3. It is 3. Sorry. So that's why here we will get 9 and here you will get 81. Okay, so here this value is I think same. Just calculate this one, but you will get this one. So here I have written 3. Okay, so 3 minus 1 square. So here you will get minus 7 square plus 2 square. 49 plus 4. So here you will get root of 53. Here you will get 7.28. So most of them we have calculated the distances from most of the given points. So just compare all the distances what we have calculated to get the shortest or lowest distance from the point 36 query feature vector. All the distances for the point 36, this one is a node. We have got 3.16. For the node 27, we have got 7. For the node 17 and 15, this is the largest one, so we have got 19.2. And for 612, we have got 9.85. And for the node 9, 1, we have got 7.28. So from here we can say that the smallest distance or lowest distance, the smallest distance is 3.16, which corresponds to the root node to the root node, that is root node is 3, 6, right? So this is the nearest neighbor to the query feature vector, that is Q23 is the root node, that is 3, 6. Okay, so we can say that. So from the options we can see that the root node 3, 6, or just you can go through that and just check for the whatever options are given, like leaf node in the left subtree 2, 7, 9, 1 and 10, 9. Check for this. So whatever distance you get the smallest or minimum, so that is the nearest neighbor of the query feature vector. Okay, so option D is the correct answer for this question. Okay, so have you understand this question? Have you got this question? Can we move to the next question? Okay, so moving to the next question. Okay, so our next question is, which of the following are the examples of the model fitting given some data point? So option A is the fundamental matrix between the corresponding points in two stereo images. Option B is homography matrix between pixels in two images of the same planar scene. Or option C is given a set of 2D points fitting straight line or parabolic curves or circle, or option D is none of above. So can you guess for this question which option should be a correct one? Any one of you? Yep, any one of you can respond if it is audible and visible. Are you able to listen me? Hello. Okay, so these are the options, and this is, let's go deep down for this question. Okay, so a detailed explanation is given here. What is a model fitting? First, see. So here we are given some observed data point, that is a 2D point, and their corresponding and features. So now we want to find out the parameters of the mathematical model, that is line, curves, or matrix, that best explain or fit the given data. So usually we use the optimization techniques like least square, ransack, maximum likelihood, and any other also. So first we will see what is our fundamental matrix, what are their contribution of the fundamental matrix between the corresponding point in the two stereo images. So now if we have two images, or if you have two images from the stereo pair, the fundamental matrix defines the geometric relationship between them, and it maps a point in one image to the line in the other. To find this matrix, we need to set the corresponding points in both images, and that process calculated by the 3 cross 3 fundamental matrix from these point corresponding. This is an act of fitting a geometrical model. This is an act of the fitting of the geometrical model to the given data point. Okay, now what homography matrix has done? Already we have solved so many questions on the fundamental matrix and homography matrix. So what is their contribution of the model fitting? So a homography is a transformation that maps points from one plane to another. It is used to relate to images with Lavati of the same planar scene, takes from the different viewpoints by providing a minimum four corresponding points in the two images, and we can solve for 3 cross 3 homography matrix. So this is it. This is also example of the model fitting, where we can find the parameters of the homography that best align the two sets of points. Okay, okay. So I don't know whether. Okay, so these are the some points, and next one is fitting a curve or line. So this is the most direct and intuitive example of the model fitting. So the given scatter plot in the 2D point, we can use the various techniques like listed squares regression to find the parameters of the straight line. That is y is equal to y. We know that the equation for the straight line y is equal to mx plus v. A parabola or a circle that minimizes the distance to all the points. that resulting the model that has been best fitted. So correct options are the three are the correct A, B, and C are the correct options for this question itself. A, B, and C are the correct options for this question. Okay, for this question. So I think something is going on. I'm not able to. Yeah. Hello everyone. Whether now it is audible and visible. Okay, so I got disconnected, so I will start from there itself. So from which point you have got till you are able to see my screen and you are able to listen to me. Question number 7, right? Till question number 7, you have got to. Okay. So question number 7, which of following are the examples of the model fitting? Given some data points. So fundamental matrix between corresponding points in two stereo images and homography matrix between pixels in two images of the same planar scene, and given a set of 2D points fitting a straight line or parabolic curve or a cycle. Option D is none of the above. Here we have already discussed in detail explanation here already previously, so it is also given. So from there we can say that option A, B and C are the correct options, because the fundamental matrix, homography matrix already we have seen, and it is used for the model fitting of the sum data point. It's one of the model fitting parameters, and also fitting a straight line or parabolic curve or cycle. It is also one of the example of the model fitting. Okay, so here detailed explanation it is given. So now next question is, using the method of least square, find the equation of the form y is equal to ax plus b that fits the data given as xy coordinate. Here that these are the data that is given x and y coordinates. So now we need to find out using the least square method that fits this equation y is equal to ax plus b. So how we can calculate this one? So any one of you, can you just correct me whether I'm audible and visible? Are you able to listen me, because I'm not getting. If you are getting, please try to unmute yourself. And okay, yes, okay. And my screen is visible to all of you. Okay, okay. Thank you, Bharati. So now for that, to fit a line equation for a line, to fit to fit a line y that is given ax plus b to this data point by the least square error. So first we need to find out their slope and intercept, that is a and v. How we can calculate using this data point the slopes and intercept? To calculate the slopes and intercept, slope a, this is the formula. So n summation of x into y minus summation of x and summation of y. Okay, and n in the denominator, n summation of x square minus summation of x whole square. This is a for slope, and to determine the intercept, that is b, it is determined by summation of y minus a summation of x divided by n. Here a is the slope. Okay, so this is the formula. Now x and y coordinates data points are given. Now we need to calculate first summation of x, summation of y, summation of xy, summation of x square, summation of x whole square. Then we will able to calculate these values. Okay. So here how many data points are given? N, that is 5. 1, 2, 3, 4, 5. 5 data points are given. Right? So here n is equal to 5, because 5 data points are given. 5 data points are given. So can you just let me know what will be the summation of x? That means summation of all the x coordinates. Okay, and summation of y similarly. Now next we need to calculate summation of x into y. Okay, so what is the summation of x? So 0 plus 1 plus 2 plus 3 plus 4. So all the x coordinates, that's 0, 1, 2, 3 and 4. Okay, so what is the overall summation? It is a 10. Similarly for y also, 1 plus 5 plus 10 plus 22 plus 38. If you add these values, you will get 76. Okay, so have you got this? So now just multiply the x and y data points and calculate this. So x, what is the x and y coordinate? So 0 into 1 plus 1 into 5 plus 2 into 10 plus 3 into 22 plus 4 into 38. Okay, you just multiply and add these values, so you will get 0 plus 5 plus 20 plus 66 plus 152. So summation of x, y, you will get total 243. Okay, so just I'm taking the new slide so that we can calculate the other values also. So now we need to calculate again summation of x square also. Okay, so you will get 0 square plus 1 square plus 2 square plus 3 square plus 4 square, right? So here you will get 0 plus 1 plus 4 plus 9 plus 16. So here you will get the total 30. Okay, yeah. Now find out the slope A, that is n summation of x comma y, x multiplied by y, summation of x and summation of y divided by n summation of x square minus summation of x whole square. Okay, now put all these values and we have calculated 5 x and y multiplication. We have calculated 243 minus summation x is 10 and summation of y is 76. Right, in the denominator 5 into 30 minus 10 whole square. Right, so if you just calculate here, you will get 12515 minus 760 divided by 150 minus 100. So here you just you will cancel 445 divided by 450. You will get 9.1 here. Okay. Similarly, we have to also calculate this intercept, that is summation of y minus a summation of x divided by n. That is a minus. So summation of y we have calculated, that is 76. Slope we had calculated 9.1 multiplied by summation of x is 10 and 5. Okay. So here you will get 76 minus 91 divided by 5. Here you will get minus 15 by 5. Here you will get minus of 3. Slope. Okay. So the best fit line would be, just put in that equation, line is y is equal to 9.1x minus 3. Here it is in this form, a x plus 3. So v value we have got minus 3 and a value we have got 9.1. So if you see the answer and options, you will get option C is the correct answer for this question. Okay. Okay. So now moving to the next question. Now our next question is, consider 2 points A 25 and B 41 in an image space. Compute the two lines corresponding to them in parameter space. Now we have to compute the two lines corresponding to them in a parameter space. So how we can calculate it? So it is the same. The equation of a line in image space that is represented by y is equal to mx plus c, right? Or ax plus b. Already we have seen that one in this form. So a and b values are given. Now first we need to convert these values in a parameter space. Okay. Then let me take the slide first. Then solve it. Okay. So the equation of line in image space is, already we know that the equation of line in image space is y is equal to mx plus c, right? Where m is our slope and the c is intercept, right? So to transform into the parameter space, what we are generally do into parameter space, just rearrange this equation. So we can write it like c is equal to minus mx plus y, right? If we take mx, so we will get this equation, right? So this equation represents a line in parameter space. This equation represents line in parameter space. Space that is in 3. So to find the lines in the parameter space that corresponds to given data point into the image space that is given. Now substitute the xy coordinate the xy coordinate in this equation for both the data point equation. So first we need to compute for the point A. First we need to compute for point A that is given 2, 5, and then we have to calculate for point B also. So here x is equal to 2 and y is equal to 5. So here you will get c is equal to minus m2 plus 5, or we can write it minus 2m plus 5. This is the parameter space for a point a is equal to 2, 5. Similarly, we need to compute for point B also. For point B, that is equal to, that is 4, 1. So here x is equal to 4 and y is equal to 1. So just put in this equation, so minus m4 plus 1. Okay, so overall you will get minus 4m plus 1. So this is the parameter space. These two lines represent in the parameter space. Two lines in the parameter space of the given point for the given point for the given point. So first equation is c is equal to minus 2m plus 5, and for the next one minus 4m plus 1. So if you check with the options, you will get option A is the correct answer for this question. Okay, so have you understand this question? Have you understand? Can we move to the next question?
Yes, ma'am.
Yeah, okay. So moving to the next question. Now next question is using random sample consensus, compute a number of samples n required which gives 99% that is probability of chance getting the pure inlier and 16.67 that is E for outliers. Also consider the minimal sample size S as a true. Choose the optimal obtained by rounding it to the closest integer. Now we need to use the RAN, that method, to compute the minimal, to compute the or to obtain the rounding to its number of samples, that is n. Okay, so the number of samples to find the least one pure inlier set. So n is computed as log 1 minus p, that is a probability of getting a pure inlier, and log 1 minus 1 p h. Okay. So where I can write it, where p is the desired probability of finding a pure inlier, pure inlier, that is given. Okay, so here p given, I'm just writing that probability, that is become 0.99, right? And E is the outlier ratio, and S is the minimum sample size. Here, minimum sample size. So here E is given as a 16 or 0.1667. S is given as 2 here. Okay. Now put in this equation. So log 1 minus 0.99 divided by log 1 minus 1 minus 0.1667 whole square, this one. Okay, so here we have also taken natural log, that is ln, we need to take. So most of the times right here, ln. Okay, so for that you have to calculate with the natural log. So here you will get natural log of 0.01. Can you calculate and let me know what will be the values? And here ln 1 minus 0.6949 4 you will get here. Okay, so if you further just calculate, so you will get minus 4.605 here in the numerator, and denominator 1 minus 1.185. So here the value you will get 3.886, that is equal to, approximately equal to 4. Okay, so the number of samples that is required for that one, that is n is equal to 4. So option B is the correct answer for this question. Okay, so have you understand this question? It is based on the formula. So, okay, it's lovely. Thank you. So moving to the next question. Now next question is suppose a query feature the distance to the nearest neighbor and the next nearest neighbor are d1 is equal to 15 and d2 is equal to 20. For the threshold ratio is 0.7, decide whether the nearest neighbor is accepted or rejected. So can you give the answer for this question? Already
So
we
it is
have
calculate D1 by D2 ratio, correct, ma'am?
yes, we need to
If it
calculate
is
the D1 by.
greater than 0.7, then it is rejected. If it is less than 0.7, it is accepted. Am I, ma'am?
Okay, if the threshold value is greater, that means this one is given. No, if this ratio is greater than, that is D1 divided by D2 is greater than this threshold ratio 0.7, then it is rejected. And if D1 by D2 ratio is less than 0.7, then it is accepted. Okay, so can you calculate and let me know what will be the ratio of D1 by D2? That is 15 by 20. So if you just calculate, you will get 0.75. So 0.75 is greater than 0.75. So this is rejected. Yes.
Yes, ma'am.
So option B is the correct answer for this question. Okay. Okay. So moving to the next question now quickly. So now next question is, which of the following is true about KL divergence for this one? Option A, it is always non-negative. Option B, it is symmetric, that is P KL P by Q is equal to D KL Q by P. So option C, it can be a negative, or option D, it is a true metric distance. So which option could be a correct one? Can you answer for this question? At least try. Okay, so we are running out of time, so I'm just explaining it. Okay, a detailed explanation is given. So KL divergence is always non-negative value. So it should be always greater than equal to 0, and it is not a symmetric, and it does not a true metric because it does not satisfy the triangle inequality. So it cannot be a negative value. Okay, so option A is the correct answer. It is always a non-negative. Okay. Now next question is, which of the following statements about discretization in the heat accumulator are true? There are multiple options can be a correct one. So option 1 is force winds increase false positives by merging any or many orbs. Second one is extremely fine winds can split orbs of a real line across neighbors and reduce peak strength. Option 3 is no discretization is needed in practical implementation. So option A is first one only, the first one is only correct, option D is second only correct, or option A first and second is correct, or option D is third one is correct. So which options can be a correct one? So here option C is the correct one. So force quantization merges different lines into the same bucket, that is a false positives. And the option 2 is also true because fine grains can split oats from noisy collinear point. And the option 3 is false because practical implementation disregards the parameters. So option C is the correct, that is first and second. These are the two other ones are the false. The third one is the false. Okay. Now the next question is, so ransack is preferred over least squares when data is completely noisy. Option B is the data contains significant outliers, or option C data is small, or option D we want exact solution quickly. So RANS preferred is preferred over least square error when. Okay, so let's check for the solutions. So RANS is random sample consensus. Already we have solved one question based on that. So that is designed for the robust again outliers. Okay, it works by randomly selecting a small subset of the data point to fit our model. And if the subset contains no outliers, the model will be the good fit for the inliers. Okay, then the model algorithm check which other data points are close to the fitted model and consider them inliers as well. Okay, so the process repeatedly iterated, and importantly, outliers are ignored during this process because of Ramsek is able to estimate model parameters even when the data contains large number of outliers. So the other options are data is completely noise-free. If the data is completely noise-free, then no outliers can be handled. In this case, least square error would be the more efficient and accurate method. And data is small, while ransom can work with a small data set. It its advantage to particular pronouns when dealing with a large data set. That means that is containing many outliers. Okay. And the option D is we want exactly solution quickly. No, no. It's also a wrong, incorrect option because Ramsek is a probabilistic algorithm. It provides good approximation of the model but does not guarantee an exact solution. Okay. So only option B is the correct answer. Data contains significant outliers. Now next question is which is true about KD tree nearest neighbor search? Option A is it always guarantees exact neural network search. Option B it always requires searching all nodes. Option C it can prune branches based on the bounding regions, or option D it does not depend on distance metric. So let's go on the deep solution or explanation. So KD trees work by recursively partitioning the data space into hyper-rectangle. Already we have solved one question. We are just dividing the data space into the different trees or subtrees. So giving the nearest neighbor search, the algorithm can use the current best found distance to a candidate nearest neighbor to prune branches of the tree. And if the bounding region of a particular search is entirely further away from the query point, then current best found distance that entire subtree can safely ignored and significantly reducing the search tree. So this pruning mechanism is based on the idea that no point within that pruned region can be closer to the query point. Okay. So option C is the correct answer, that is KD tree uses bounding box and distance to prune search space. Okay, it can prune branches based on the bounding region. Okay. Now moving to the next question also. In a 2D KD tree, the splitting axis alternates between always x-axis, option B always y-axis, or option C x and y-axis alternatively, or option D is random axis. So I think you guys can answer at least for this
C,
question.
madam. Option C.
Yeah, option C is the correct answer. It alternately just divide split on x and y axis. So next question is which of the following is not an example of the model fitting? Estimating fundamental matrix from stereo correspondences, or estimating homography for planar scheme, or option C fitting a straight line to 2D point, or option D is sorting a list of numbers. So already we have seen one example. Which of the following is not an example of model fitting? So already we have seen in the previous question estimating fundamental matrix from the stereo correspondence. This is the example of the model fitting, right? Or estimating homography is also example of model fitting, and fitting the straight line to in 2D points also a model example of. Only sorting is not a example of the model fitting. So that's why option D is the correct answer for this question. Okay. These are the examples of the model fitting. A, B, C are the examples of the model fitting. We have solved many questions on that. Okay. Model fitting. So option D is the only correct. A detailed solution I have given in the next two slides. So you can see in the later part. Okay. Now next question is if the pullback Leveler divergence between two probability distributions P and Q is zero, what can be concluded? Option A, the distribution P is a constant uniform distribution. Option B, the distributions are mutually exclusive. Or option C, the two distributions P and Q are identical, and option D is the distributions are independent. So what would be our answer if the correct, or you can say KL divergence between two probabilities, the distribution P and Q is zero, what we can conclude. Okay, so moving to the solution at the field answer here given. So KL divergence often denoted by D, KLP by Q already we have seen, that measures from the information theory that quantify the difference between the two probability distributions P and Q, and it measures the information lost when Q is used to approximate P. So the key properties of the KL divergence are non-negativity. Already we had seen that the value of KL divergence is always greater than or equal to 0. Okay, and 0 value. Also, the KL divergence is 0 if and only if the two distributions are identical, that is Px or equal to the Qx. So option C is the correct answer. The two distributions P and Q are identical. If the KL divergence between two probability distribution P and Q is 0, that means the both distributions are identical. Okay. So now moving to the next question. Given two different probability distribution P and Q, which statement about KL divergence is true? That is, P Q will always equal to the QP, and PQ will always depend from the KL divergence of QP, or PQ is generally not equal to DKLQP, or it is always a positive number, while DKLQP can be a negative. Which option can be a correct one? Given two different probability, if the probability of both P and Q are different, then which statement can be concluded? So it should not be always equal. This is not a correct answer. So this can be a correct answer. Okay, generally not equal to, yeah, this one also. So let's deep down to the solution, deep to explanation. So KL divergence is a non-symmetric measure, which means the KL PQ is not should not be equal to QP. In most of the cases, the order matters because each calculation measures the information lost when the specific distribution is used to approximate to other one. Either it can be a P or it can be a Q also. So the DKLP Q measures the information loss where Q approximate P, and in the QP measures the information lost when P approximate Q. Okay, so basically correct answer is C. DKLP Q is generally not equal to the KL divergence of QP. Okay, so option C is the correct answer. Generally not equal to QP. Now next and last question is, what is the significance of minimal sample size S in the rank-set algorithm? So already we have seen, so we have solved so minimum sample. So what is significance of that minimal sample size S? So option is, it is a minimum number of data points required to compute the final model. Option B, it is the number of iterations the algorithm will run. Or option C, it is the smallest number of data points required to uniquely determine the parameters of the model. Or option D, it is the threshold for classifying a point as a inlier. So already I have described in the question and that formula. So what is the minimal small size? So here already given. So the minimal sample size S is a crucial parameter in rank. It defines the number of points that are randomly selected in each iteration to propose a candidate model. So this number determined by the model itself. For example, here example is given. If to define a straight line, you need at least 2 points. S is equal to 2. To define a circle, you need at least 3 points, and to find the homography, we need to at least 4 points. So correct answer is C. It is the smallest number of data points required to uniquely determine the parameters of the model. Okay. Option C is the correct answer for this question. Now the questions have been completed. If you have any questions and doubt, you can ask. Otherwise, we can close the session. So thank you everyone. Thank you for joining this session. So I have
Uh,
here combined the most numerical and as well as conceptual and theoretical questions itself, so that it will be the
Thank you
easy
so much,
question.
madam.
Okay.
Today is Ganesh immersion today. In spite of that, we are
Okay.
able to
Okay.
attend the class. I think same is the case with you.
Yeah. Yeah. Same.
Thank you so much, madam, for your patience and very clear explanation.
Okay. Okay. Thank you. Thank you for
Thank you,
joining this
ma'am. Good
session.
night.
Okay. Thank you. Thank you. So if you don't have any doubts, you can leave the
Yeah, ma'am.
session. Okay. Any doubt? Anything else? Filavati? Okay. So now I'm closing the session. Thank you. Thank you for joining this session. We will meet for the next week.